Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. I have to admit, realizing it is somehow late August was a bit startling. I'm not sure entirely where my summer went, but I'm grateful that my garden is finally producing veg and the temps are starting to slowly trend downwards. The dog days of summer are named for the appearance of the dog star Sirius rising with the sun. Running from July 3 to August 11, these are typically the hottest days of the year, and once upon a time in the Roman Empire, that heat was blamed on Sirius, the brightest star in the sky, being in close proximity to the sun. Today we know that just isn't so, but it makes for a good story. With the dog days behind us, Orion is creeping its way higher and higher into the morning sky as it works its way over towards an evening appearance. Along with Orion, we also have the planet Mars making a pre-dawn appearance beside Jupiter above Orion's head in the constellation Taurus. It too will be rising earlier and earlier as our planet races closer in our orbits. We'll be finally passing Mars in January, and in the coming months, we'll be able to watch as it appears brighter and earlier in the sky, night after night. The sky is returning to my favorite state, and I am here for it. In the past, research related to Mars was restricted to Mars's close approaches. Today, with rovers and orbiting spacecraft aplenty, every day can be Mars Research Day. Well, every day except the dozen or so when Mars is directly behind the sun. Today, in our closer look, we examine new results about Mars water, Mars sample return, and our dreams for fossil hunting on the red planet. We also look at the origins of the asteroid that killed the dinosaurs, the environments of fast radio bursts, and a black hole chowing down on a star. All this and more is coming to you right here, right now, on Escape Velocity Space News, a product of CosmoQuest, and supported through our Patreon. The single messiest day in geologically recorded history was the day the dinosaurs died. On that day, and across the days that would follow, tidal waves wrapped multiple times around our world as first a primary impactor hit our world, and then, as the rocks it threw into the air, rained back down in an atmosphere-baking rain of destruction. One of the main reasons we know about that one really messy day is a strange layer of iridium and other elements that separates the layers of rocks containing a diversity of dinosaurs and the layers that came after. This layer of material, the KPG boundary, wasn't made of material from our world. 44 years ago, Louis and Walter Alvarez posited that this iridium layer was associated with an asteroid impact. And we now know it was from a 10 to 15 kilometer across asteroid hitting the Yucatan Peninsula 66 million years ago, forming what is now called the Chicxulub crater. And thanks to a new article in Science, we now know that asteroid came from the outer solar system. The origin of the Chicxulub crater and other craters were determined by a team led by Mario Fischer-Godi. He and his colleagues collected samples from the KPG boundary and measured high levels of platinum group elements like iridium, ruthenium, osmium, rhodium, platinum, and palladium. These elements are rare on Earth and much more common in asteroids. Further, since different parts of our solar system allowed objects with different compositions to form, they knew the ruthenium isotopes they found are consistent with the impactor being a C-type asteroid that formed in the outer solar system. This work appears in the journal Science. The team's research was also able to show that 5 other impact sites were formed from stony S-type asteroids from the inner solar system. I am now interested to see this work carried out with more craters. There are about 200 known impact craters on Earth, and I'd love to know what parts of the solar system have attacked us over time. In addition to just being neat, this kind of information will both inform future risks and help us understand where the materials that shaped our world have come from over time. A whole lot of time in astronomy and space science is spent going, that's weird, and then trying to figure out what the weird thing is. From spotting and decoding a weird layer of iridium in the landscape to spotting and trying to make sense of weird things in the sky, our job is to uncover the evidence that leads us to the truth behind every weird thing in our data. In 2007, a student discovered a really weird thing in archival radio data. David Narvek was working with Duncan Larimore and found a 5-millisecond burst of energy in the radio that appeared to be of extragalactic origin. In the years since then, over 100 of these objects have been discovered, with a few of them repeating on a regular basis. No one had predicted something like this should exist, and figuring out what exactly we're seeing has been a wild ride. And the ride has not yet reached the end. Based on what we've seen so far, the radio bursts are caused by high-energy, highly localized, short-lived events. Because light takes time to travel, we know that millisecond duration pulses must come from sources less than 1,000 kilometers in size, and objects like neutron stars or maybe stellar mass black holes would fit the data. And theories of their origins include magnetars, highly magnetized neutron stars, or some kind of snacking black hole or neutron star that is taking large bites from a companion. These kinds of origins could leave telltale evidence in the form of faint and persistent radio emission. These have now been seen 3 times, and it is starting to be possible to build a model that includes both a high-density object and a surrounding nebula that emits a persistent, fainter radio signal. This is super cool for a couple of different reasons. On one hand, this means that when we see a fraction of a second-long burst of radio, we can pinpoint its origins by looking for its home nebula, at least when the source is close enough for those to be seen. It also means we have a more complete model of what's going on that includes a high-density source surrounded by a nebula that may be surrounded by the remnant of a supernova. This work appears in Nature and is led by Gabriele Bruni. Our ability to fully understand these objects is limited by our ability to find them nearby. But we don't want to find them too nearby. It's worth noting the kind of energy released by these objects can destroy nearby solar systems, or at least the atmospheres of planets and nearby solar systems. There's nothing near us that we know of capable of becoming a fast radio burst, and I think it's fair to say we're okay with the challenge of looking at things far, far away. One of the challenges of observing fast radio bursts is catching them in the act. While we have telescopes that work hard to spot things that go flash or flare in optical X-ray and gamma ray light, that same kind of large-scale monitoring just isn't as easy in radio wavelengths. While monitoring the sky with optical systems, we've found some really weird stuff. Back in 2018, the All-Sky Automated Survey for Supernovae discovered a brightening galaxy. Follow-up observations in the X-ray found the kinds of high-energy light that signals a black hole is tearing apart and feeding on a star. When the light faded away, it was assumed the star was gone and the excitement was over, but it returned about 1,200 days later. The second flare wasn't as impressive as the first, but it was enough to let researchers calculate the shredded star's orbit and predict when whatever remains might be gobbled up. According to researcher Erik, Quote, "We think that a third meal by the black hole, if anything is left of the star, will begin between May and August of 2025 and last for almost 2 years. This will probably be more of a snack than a full meal because the second meal was smaller than the first and the star is being whittled away." Of course, it also might not. It could be the star has been completely consumed or something we can't anticipate has occurred. The universe doesn't always do what we expect. Let's consider for a moment the star system T Coronae Borealis, appearing as a single star in your standard backyard telescope. This is a binary star system consisting of a white dwarf and a red giant star. Over the decades, this system has been seen to radically increase in brightness every 79 to 80 years, and it was predicted the next brightening, or nova, would occur this month, August 2024. As of this episode's recording on August 20th, the system has done nothing. But it should do something. So, the Coronae Borealis system is observable in the evening sky through late November when it sets for the winter. It can be seen easily with small scopes, and there are finding charts linked from our website, evsn.tv. Here's to hoping that the system goes off sooner than later. It would be super frustrating to have it go nova when the system is only up during the day. Sadly, the universe is going to do what it wants to do, and it doesn't care about our day-night cycle. Up next, we take a rapid-fire look at all the science coming out of Mars research community. Stay tuned. Since Mars Spirit and Opportunity first set down on Mars in 2004, there has been a continuous robotic presence on the red planet. The Phoenix and InSight landers have answered specific questions about Mars' composition and interior, while a small herd of rovers and even a helicopter have explored terrains that appear to have once been awash in water. While NASA's current major focus is the Artemis program and the return of humans to the lunar surface, this work is all being done with a look ahead toward future human missions to Mars and asteroids. The desire to go to Mars is complex and brings together all our sci-fi desires to be a multi-planet species with all our scientific desires to get to walk on the surface of another world and explore for signs of ancient life. I, for one, hope to someday see humans fossil hunting on Mars. My hope and the hope of other researchers to find signs of ancient life rests in our understanding that Mars had vast oceans at about the same time that life is known to have started here on Earth. The question becomes, does Mars still have liquid water? We know it can't have any on the surface. The current pressure and temperature at Mars' surface is such that water can exist as ice, and it can exist as gas, but liquid pretty much instantly transforms to gas. There is some evidence that maybe super salty water exists near the surface and periodically wets the soil, but this isn't the kind of water that is going to allow liquid-loving life to thrive. But what about deeper? The InSight lander spent 4 years measuring quakes from its location near Mars' equator. These quakes were generated by small asteroid impacts, seismic quakes, and other events. As seismic waves from all these sources move through Mars' interior, the waves can bend and their speeds can vary as they pass through regions of varying density. Measurements of how all those seismic waves were affected by Mars' interior allowed scientists to map out what's inside Mars. In a new study presented in the Proceedings of the National Academy of Sciences, researchers led by Vashan Wright present a new analysis of the InSight data that seems to trace out the presence of rock saturated with liquid water at depths of 11.5 to 20 kilometers. The amount of water detected is sufficient to cover the entire planet in water to a depth of 1 to 2 kilometers. This indicates that past oceans may have filtered down through the Martian surface to saturate the rocks lower down in the planet's crust. Unfortunately, this research found the rocks closer to the surface are dry. And it may be that Mars only has accessible water in the form of ice at its polar ice caps. According to co-author Michael Manga, quote, establishing that there is a big reservoir of liquid water provides some window into what the climate was like or could be like. And water is necessary for life as we know it. I don't see why the underground reservoir is not a habitable environment. It's certainly true on Earth. Deep, deep mines host life. The bottom of the ocean hosts life. We haven't found any evidence for life on Mars, but at least we have identified a place that should, in principle, be able to sustain life. End quote. To be clear, there is no expectation of little green men living 15 kilometers below Mars' surface. It is merely possible that small, not intelligent life, like bacteria and microbes, might exist in the Martian crust, just as we find life in the rock of deep mines here on Earth. Sadly, it is looking more and more like any attempts to find life on other worlds in our solar system are going to require significant mining equipment that we can sterilize. From kilometer-thick ice shells protecting oceans on moons of Saturn and Jupiter, to kilometers of rock protecting water-rich rock on Mars, water is staying tucked away. Given we don't have the ability to sterilize stuff very well at the moment, this may be for the best. I don't think any of us want to either kill all life on Mars with our own germs or have it kill us because we are bad at quarantining samples. While looking for life living deep in the subsurface water of Mars is both a bad idea and not technologically possible at the moment, we do have other life hunting options. The Perseverance rover has been collecting rock samples and drilling cores as it travels through Jezero Crater and its former river delta. Since February 2021, this rover has collected 22 rock cores as it traveled roughly 30 kilometers. Among these samples are 7 from along the front edge of the river delta's fan-like structure. These samples appear to be made of layered sedimentary rock that was built up during Mars' wet past. According to study lead Tanya Bozak, quote, these rocks confirm the presence, at least temporarily, of habitable environments on Mars. We found lots of minerals like carbonates, which are what make reefs on Earth. And it's really an ideal material that can preserve fossils of microbial life, end quote. This work is published in AGU Advances. Unfortunately, Percy wasn't designed to detect organic molecules with certainty. Some of its instruments, like Sherlock, have the ability to look at how ultraviolet light interacts with the minerals, and while this can identify rocks that could contain organics, and it has identified rocks that could contain organics, it is also possible that these are other kinds of molecules that just happen to behave the same way. Ultimately, we need to get all of Percy's rock samples back to Earth where we can study them in large and well-equipped labs that are both larger and require more power than we have the ability to send to Mars at this time. While a Mars sample return mission is planned, its timeline is uncertain, and I'm not sure anyone would be surprised if humans made it to Mars before a Mars sample return mission can be realized. As we learn more about the future of Mars sample return and other missions, we'll bring it to you right here on EVSN. Up next, we have Tales from the Launch Pad with Erik Madaus. Stay tuned. Next up, I'm pleased to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launch Pad. Hey, Erik.
Hi, Pamela. On August 3rd, SpaceX launched the NG-21 Cygnus for Northrop Grumman on a Falcon 9. Let's watch the launch.
5, 4, 3, 2, 1, ignition, engine full power, and liftoff of Falcon 9. Go SpaceX, go Cygnus NG-21.
Falcon 9 and Cygnus take flight. The SS Dick Scobie is en route to the International Space Station.
Stage 1 propulsion is nominal.
Northrop Grumman is temporarily launching Cygnus resupply vehicles to the ISS on Falcon 9 after its supply of Antares rockets was depleted. Northrop expects to have its replacement, the Firefly Medium Launch Vehicle, proper name GBD, ready next year. This Cygnus was named the SS Francis Richard Scobie, after the astronaut who died in the Challenger disaster. NG-21 carries about 4 metric tons of cargo and will use its main engine to reboost the ISS during its stay. On August 6th, China launched the first 18 satellites for the Space Sail constellation from the Haiwan spaceport. Let's watch the launch. Space Sail is intended to be China's Starlink competitor. The satellites are designed in the same flat pack format and stack similar to Starlink, but have completely different antenna designs. The relatively new Long March 6A carried the satellites into orbit. Unfortunately, following the successful spacecraft separation, the upper stage of the rocket once again exploded, leaving hundreds of debris in space. The Long March 6A upper stage has exploded on 4 of the 7 launches, including the last 3 consecutive flights of the rocket. Something is seriously wrong with the design or passivation operations of the stage, as shedding hundreds of pieces of debris into orbits they'd like to use for their satellites is almost certainly unintentional. On August 11th, Rocket Lab launched the A Sky Full of Stars mission on an Electron rocket from the New Zealand spaceport. Let's watch the launch.
4, 3, 2, 1. Liftoff. Safe launch pad. Beginning picture.
A Sky Full of Stars carried the third Acadia satellite for Capella Space. Acadia is a series of synthetic aperture radar satellites. Radar satellites can image the Earth at all hours of the day and through any weather. On August 12th, SpaceX launched the Arctic Satellite Broadband mission for Space Norway on a Falcon 9 out of Andy. ASBM is a constellation of 2 satellites that have a forest of antennas for multiple users. Their primary mission is to offer mobile broadband for civilian use. Both satellites have payloads from Inmarsat for civilian use, Space Norway for the Norwegian military, and for the U.S. Space Force for the U.S. military. The 2 satellites were inserted into a Molniya orbit, a highly specialized orbit that maximizes the time they spend over the North Pole. It was first developed by the Soviets for their communications and intelligence satellites. It's particularly useful because the satellites in this orbit stay at the same relative angle around the Earth without expending excess fuel. The 2 ASBM satellites are in the same orbit with different positions in the orbit, such that when one satellite is setting from Norwegian ground stations, the other is coming into view. This angle is called the argument of perigee. On August 15th, SpaceX launched the Worldview Legion, also called Maxar, 3 and 4 satellites on a Falcon 9 from Flight 40. Let's watch the launch.
1 ignition. And liftoff Falcon 9. Go Worldview Legion.
Vehicle switching downrange.
Emily, team Bridge Pamela.
Worldview Legion is a constellation of medium Earth orbit imaging satellites. 2 more will be launched for a total of 6. On August 15th, India launched the 3rd small satellite launch vehicle on a demonstration mission carrying EOS-8, an Earth imaging satellite for the Indian Space Research Organization, ISRO. Let's watch the launch.
5, 4, 3, 2, 1, 0. Plus 5 seconds. Normal.
The SSLV is a new rocket developed by ISRO for launching small satellites up to 500 kilograms in weight. It has now completed its flight development program with 2 successful flights. The first was a failure, but an easy fix. The launch also carried a CubeSat from Indian company Space Rickshaw. On August 16th, China launched the Yaogan 43-1 mission into orbit from the Xichang spaceport. Yaogan is a huge program of government intelligence satellites for varying purposes, with a civilian cover name. Usual clusters of Yaogan satellites number 3 or 4, but this one had 9 satellites, as noticed by clever Twitter users who saw 9 stars on the mission patch. The U.S. military agency responsible for tracking space objects later confirmed 10 objects, the upper stage of the rocket and the 9 satellites. Chinese officials described the Yaogan 43 satellite mission as not the usual boilerplate land use and disaster relief or crop yield estimation, but instead they would, quote, carry out new technology experiments for the low Earth orbit constellation system. On August 16th, SpaceX launched Transporter 11 on Falcon 9 for Vandy. Let's watch the launch.
5, 4, 3, 2, 1, ignition. And liftoff of Falcon 9. Go Transporter 11.
Vehicles pitching downrange.
MOD chamber pressure nominal.
Transporter is a series of semi-annual launches of small and medium satellites on Falcon 9 rockets. Most of these are from companies that buy lots of space on the rocket and sell it to smaller users, managing all steps of getting their payload approved for launch and on the rocket. Some of them deal directly with SpaceX, but not much. Transporter 11 carried 116 satellites, the usual assortment of government, commercial, and scientific satellites. One that caught my eye was the Arctic Weather Satellite from ESA. It's operated by the European Union Weather Satellite Agency, EUMETSAT, and will test technologies for future polar orbiting satellites operated by ESA. We track launches with the help of RocketLaunch.live. So far this year, the United States has had 90 launches, China has had 37 launches, New Zealand has had 9 launches, Kazakhstan has had 5 launches, Japan and Russia each have had 4 launches, India has had 3 launches, Iran has had 2 launches, French Guiana and North Korea each have had 1 launch. Of these 156 launches, there have been 4 failures, reminding us that space is hard.
Thanks, Erik. Before we go, I have a new mystery for you. Researchers, with permission, took a small sample from the altar stone at Stonehenge and examined its composition and structure in a new level of detail. This information made it possible to determine the stone is 1,000 to 2,000 million years old and chemically similar to rocks in the Orcadian Basin of Scotland. This research was a bit of a surprise to everyone because it had been assumed that this stone, like others, came from Wales. Stonehenge was built about 5,000 years ago in southern England. With one exception, it consists of 2 different types of stones, the Great Sarsen stones and smaller blue stones. The smaller stones are well matched to a site in the Preseli Hills of Wales, and the standing Sarsen stones are a match to a quarry 15 miles north of Stonehenge in England. And these 2 different quarries explain all but one of the 160 some odd stones that make up Stonehenge. The odd rock out was the altar stone, which is flat with the ground, and is uniquely made of sandstone. And for reasons that have everyone scratching their heads, it really looks like that 1 6-ton stone was moved over 700 kilometers from Scotland to the south of England. Why? No idea. How? We can only guess. It is possible that the Neolithic people were able to somehow transport it by boat. This would imply the early Brits were far more organized than previously thought. And they were organized around constructing something capable of predicting eclipses and measuring seasons. I, for one, support our early ancestors focusing island-spanning endeavors on setting things up to, among other things, study the sky. That's it for now. Good night, everyone. And remember, go out and look up.